Welcome back. In this video, we will be adding our game mechanics, that being the maze's rotation to guide the player towards the goal, meaning the ball towards the goal, which is the bottom. So let's start then. For that, we will need to add a constant force component to the maze, so we can make it rotate in the direction we want. To make that happen, we'll need a game object to contain our maze, a parent game object, so to speak. So let's go ahead in our scene here in the hierarchy, right click and create an empty game object. So this game object will now be empty because it doesn't have any content. It only has a position, nothing else, no components, no other game objects. But what we want to make out of this is going to be the parent. The idea of a parent game object is that it can hold a bunch of children game objects. So what we want to do is we want to position all of our maze elements inside of this parent so that we can move the maze around without having to move every single individual piece around, but just the parent. So what we want to do is we want to position our 4 walls inside of the parent. But before we do so, let's make sure that our parent is actually going to be in the center of our maze, because we want to move around the maze back and forth, right? In order to do so, let's first of all reset our parent. So click on the parent and then reset it in the inspector by clicking this button here and reset. And then we want to make sure that we position it in the center. So you see, if you click on this square here in the center, you will get the front view of your game. And what we want to do is we want to now change the parent's position to be in the center, so to speak, of our maze. And the center in our case is going to be at 7.5. This is going to be the center because if we look at it, this part here, it has an X value of 15, which means it has a height of 15, and the center of 15 is 7.5, which is why right here is where we want the parent to be in the center. And now we can go ahead and drag all of the walls into our parent. So you can use the shift key in order to mark multiple items at the same time, or you can just press the control key and then add items to the list of selected items. So in my case, I'm going to now drag it into the parent, and now we can close the parent. So we could have called this one maze, for example. That would have been fine as well. But for now, parent is fine for you to understand the concept of what is going on here. So this is going to be the parent of all of those child items, so to speak, of the ground, left wall, and so forth. You can also check that by looking at it from the side. So now let's look at the parent, and you see it's in the center of this line here. So we're looking from the side, so to speak, and this allows us to see where the center is. All right, this is, by the way, isometric, and now we can add it to be perspective. So here you can change the setting by clicking on this little button here on the top right hand side. Okay, now let's actually play around with this a little bit. So click on the parent, go to the front, click the square here to go to the front, so to speak, here to have this front view, and then select the rotation tool here at the top left hand corner. And now you can rotate, for example, with the blue line, you can rotate the parent, and by rotating the parent you can see we are now rotating the entire thing. And this is what we want to be able to do. We want to rotate the entire maze using buttons later on. So now let's go to the default values that we have defined for our parent, and that was 0 for the X position, 7.5 for Y, and 0 is at 0 as well. There is no rotation at all, so all of those values are set to 0. So now it's time to make the parent rotate through our input. And it's easy as adding a constant force to it. So let's add a component, and here you can just search for constant force. It's going to be this one. And now let's add this. So now you see our parent suddenly has a rigid body as well as a constant force assigned to it. Because a constant force needs a rigid body for it to work, because without physics, which the rigid body adds to it, the force cannot be applied. So as you see, we didn't even have to add the rigid body ourselves. It was done for us by Unity directly. So let's make it rotate then. For that, first set its angular drag to 0. So it's this one here. because we don't want to simulate resistances. And then let's freeze the position towards all directions and rotation, except for the Z rotation. So now it will only be able to rotate in the Z direction. It will not be changing its position. So even though gravity is turned on, it will not have an impact on our parent because, well, physics will be activated, but we are freezing the position. So we are overriding, so to speak, the gravity that it would usually do. And we're also making sure that the rotation is only going towards the Z direction. So basically, if we look at it, this blue axis, as you see in the top right hand corner, if you look here, is changing the Z rotation. So the Z value here, and that's exactly what we want to do. So now let's test this by adding a relative torque. So a torque of 40 for the Z value. So I'm setting the value to 40, and now let's run it. Let's see what's going to happen. And you see our game is actually rotating. And also maybe we should change the camera position because it's not very good where it is right now. We want it to be at a position where we can actually see the entire game. Therefore, you can go to your moving tool and then move this green bar, and you can see that now we're in the center of it. But at the same time, we need to move back a little bit so that we can actually see the game. So probably a good value would be something like a position of 8 or even 7.5, I believe would be the center. So let's put that to 7.5, and the Z value at something of -15 or maybe even -18, where we're a little bit further away. And now let's run this again and see how the torque is rotating our maze. And it's constantly rotating towards the 40 degrees, and then you see it's happening again. Basically the physics are impacting each other. So here you see our player is impacting the maze also. So that is basically because of the weight of the player, and that adds resistance to the rotation, and well, basically it's big enough so that it can't overcome it. An easy fix would be just to make our player as light as it gets. So we can go to our player and go over here to the rigid body, and you see it has a mass of 1. So now let's change the mass to a super low value. So here you can use 0.000 and 1, for example, and you can see the lowest value that it gets is 1e minus 7. Basically it's a 0 with 7 zeros after the comma separator or the dot separator in English, and yeah, it's basically 7 zeros and then the 1 coming at the end. So that's what this 1e07 means. Okay, so now let's check it out again, and let's see how it will be impacting the rotation. You see the rotation is barely impacted at all by our ball, and now the force is big enough even for the player, and I'm getting sick of this, for the player to be stuck at the corner. Okay, so that's what we achieved by changing the relative torque to 40. Okay, so now what I would like to do is I would like to be able to rotate towards both directions. So not only towards the left-hand side, so counterclockwise, but I would like to rotate clockwise. Of course, I can change the torque here to something like -40, for example, and then it will rotate in the other direction, as you see now. But that's not what I mean. I would like to be able to then later on have two buttons, one that will tilt it towards the left and the other button which will tilt it towards the right. And in order to achieve that, we will need to have another constant force. So let's try to add this constant force component to our parent once again. And you can see it says the component constant force can't be added because parent already contains the same component. So you cannot add the same component twice to a game object. So that's something that we need to be aware of. So what we can do to play around it is to create another empty object, which I'm going to call superparent. And now this superparent will have the same details as the parent. It will basically be at the position of 7.5 for the y coordinate. And then it will need to have the constant force also. So let's add this constant force. And now the relative torque will be minus 20, let's say. Okay, so it will be going towards the right-hand side with a certain speed. We are also going to freeze the position, so it should not change its position itself. It should just rotate towards the Z coordinate, nothing else. And now, of course, my parent has to go into the super parent. So let's drag the parent over to the super parent. And now they will both interact with each other. If we run the game now, we will see that we have this super weirdish behavior here. And that is because one relative torque is minus 40 and the other one is minus 20. So if we change both of them to be minus 20, so for example, for my parent, it will also be at minus 20. If you run it now, you will see that those forces, they will counteract with each other. And then the ball will play a little role as well. So we're creating this wobbly effect, so to speak. So in order to change that, what we can do is, let's say we deactivate the physics of our parent. So we add the isKinematic here, which basically deactivates the physics directly run by Unity itself. And you can still apply physics using your code. But as we're not using any code in this example, we will need to play around with it this way. So basically, we're just using this concept of parent and super parent because we're not using code. If we were using code, we would make it a lot easier for ourselves and we would just play around with the relative torque. But as we're building this game without writing a single line of code, we need to have this little workaround here with our super parent and parent. So we can basically activate the physics of them once we need them and make them move towards one or the other direction based on our own input. So now let's also make sure that we are setting the value of the constant force to 0 for our parent. And if we run this now, then our super parent will kick in and you can see now it's rotating towards the right and it's going super fast. And our ball is jumping on the wall. All right, so that's it for this video. In the next one, we are going to implement the UI that will allow us to then press the left or the right button in order to move the parent or our maze towards one or the other direction. So see you there.